Hey everyone, SV Math Teach here. Welcome back. Remember, before you watch this video, feel free to like and subscribe if you like what you see and you like the price, which is $0. All right, let's begin. Today's lesson is on proportional relationships. Now, a lot is made of proportional relationships. Sometimes they appear very difficult. They don't need to be. Proportional relationships are simply relationships between two variables. In my example here, gallons of gas and the cost for those gallons of gas. And what you'll find with proportional relationships is two things. One, those relationships always start with or contain the ordered pair 0, 0. That's right down here. So if you see a graph that is linear, first of all, so straight line, and second, that it goes through the origin, it is always going to be a proportional relationship. Now, the second thing that you'll notice is that it has a unit rate. Now, a unit rate you've studied before. A unit rate is simply taking the y value and dividing it by the x value. So, for example, I'm going to choose two different points here. I'm going to choose this point right here where my y value is $4 and my x value is 1.5 gallons. And if I divide that out, I get 2.6 repeating. Now, if I find a different point on this line, let's choose this one up here. Notice that is going to be $8 divided by 3 gallons. That's going to equal 2.6 repeating again. Notice how I could pick those two, or I could have picked anything else, but those two definitely lined up better than a lot of the other ones. I could choose any point and divide the y by the x and always get the same unit rate. And then for what it's worth, I can go ahead and write an equation. The generic version of the equation is often referred to as y equals kx. K is this thing they call the constant of proportionality. A lot of your teachers will swap the K out for an M, and M stands for this thing called slope. And slope is really just the unit rate. So in my example right here, I would write y equals 2.6 repeating x, which means every time I have an x, all I need to do is multiply it by 2.6 repeating to get the y, which means 1 gallon of gas costs $2.6, right? There's your 2.6 repeating. So that's what we're looking at. That's what a proportional relationship is. If you've worked as a babysitter, you've probably earned money as a proportional relationship. Every hour you work is more dollars you earn. Cutting grass, working at a job, just about anything that you do, unless it has some sort of starting value. If the starting value is 0, like if you don't do anything, you don't get paid anything, then that's a proportional relationship. So with that in mind, let's look at 3 different examples. There's that phrase, constant of proportionality. So with that in mind, I have 3 different items here. 3 cereals that I'm comparing, because oftentimes a question might be, what is the constant of proportionality, which is code for what's the unit rate, and then oftentimes compare them, order them, or write equations describing them. When I do problems like this one, I find myself wanting to have a calculator nearby, so here's my calculator. Now, the Captain Crunch box on the left, 24-ounce box, costs $3.29. You could do 2 things here. You could, if you wanted to, just make one equation, y equals 329x. But the only difference would be this would be the number of boxes, and this would be the cost of those boxes. Now, there's nothing wrong with that, right? That's a perfectly acceptable unit rate. However, these things over here aren't described as boxes, and these over here aren't described as boxes either. You'll notice that this is in ounces, and this is in ounces. So we're not really comparing the same things, right? Comparing the amount per box to an ounce cost isn't going to help you out. So instead, I'm going to go ahead and, while that is perfectly acceptable, I'm going to swap it out for something else. I'm going to take my $3.29 and divide it by 24 ounces, and I'm going to say it cost me approximately 13.7, or I'm going to round it to 14 cents per ounce. So y equals 0.14x. In this case, x is going to be the number of ounces. That also lines up really well with the fact that the number of ounces is listed first, and the number of ounces over on the right-hand side is listed on your x-axis. So we have 14 cents per ounce and an equation. Let's do the bulk granola. Now, if this is proportional, that means that any of the y's divided by any of the x's will give me exactly the same thing. And I could test this out, right? 0.9 divided by 6 is 0.15. 2.40 divided by 16 should be the same thing. It is. And 3.90 divided by 26 equals the same thing. So if you're ever asked, is this a proportional relationship, you can just divide the y by the x and you should always get the same thing. I did, so I'm going to go ahead and write down y equals 0.15. So that tells me it's 15 cents per ounce. So it's more expensive than the Captain Crunch. And one last item on the right-hand side, let's do the bulk rice cereal. Now I must admit that I used to have a grid in the background on this, and it looks like I lost it, but I do have some dots remaining. I'm going to go ahead and hope for the best on this. I think this dot agreed with 10 ounces and $1. So I'm going to go with that, and I'm going to say if I have 10 ounces divided by 1, this shouldn't surprise me. I guess I should have dollars, right? So 1 divided by 10, because we always do y divided by x. So I almost made a mistake there. So my y is my 1, and my x is my 10. So 1 divided by 10 equals 0.1. So y equals 0.1. I'll put a 0 on it because we're dealing with money. But this is my constant of proportionality for bulk rice cereal. So if I were ordering them from smallest value to greatest value, this is the least expensive at 10 cents per ounce. Captain Crunch is 14 cents an ounce, and the granola is 15 cents an ounce. And remember, one more time, 2 things for constant of proportionality: always divide y by x, and always make sure they go through 0, 0.